let's move now to the second part of this chapter, which is about the equations of motion in kinetics for rigid body. And what are these equations, guys? If you remember, they are that the sum of forces is equal to ma/dx, sum of forces in y is equal to ma/dy, and if this is a translation, then the sum of moment around g will be equal to 0, and if you want to take it around any point A, you can do this by finding the moment of the resultant force that is equal to mag times the distance to point O. So let's apply this to the first problem here. And this is the last problem that I'm going to solve in the solving session. I have a 150 kilograms uniform crate that rests on the 10 kilograms cart. I need to determine the maximum power that can be applied to the handle without causing the crate to slip or tip on the cart. The coefficient of static friction between the crate and the cart is μs is equal to 0.2. Now guys, if you imagine this motion, and you imagine that I am pushing this crate with a force of P, then you can imagine, guys, that this tip will occur at a point A. Okay, so A, guys, what happens is that this one will lose contact with the crate, with the cart, and then it will be like this. This is point A, and this is the crate. So I can have this one, guys, and then A could slip in this direction. So A, guys, could have a slipping in this direction, all right, and this crate could have a rotation. All right, if I want to find the maximum P before taking the cart as my free body diagram or the whole system as my free body diagram, let's think about the crate only. What are the forces exerted on this crate? If this point here loses the contact with this cart, then there is no normal force here. However, I'm going to only have a normal force that is at A. So this is my normal force. And then I'm going to have the weight of the crate. And I can have a friction force because I know μs. All right. So these are the forces that could be exerted on this crate. Now, the question is to find P. In order to find P for the whole system, I have to find the acceleration of the whole system, and applying some force in x direction is equal to ma. How to find this acceleration? If I know the acceleration from this one, from this free body diagram, I can take this acceleration and apply it to the whole system because, of course, they're going to have the same acceleration. Now, how to find the acceleration of this crate? In fact, as I said, if I have only a translation motion before the tipping, then the sum of moment around point A is equal to the moment of m times A, the acceleration, times the distance between this ma and this A, right? So if I want to do the sum of moment around A, and I'm going to put it equal to 0 because I have to find P that can be applied without causing the slip, just before this slip or tip. All right, so right now it will not occur. This slipping or tipping will not occur. I'm gonna do this just before the slipping. So what is the sum of moment? If this is the acceleration, because this is in fact P, so this should be the acceleration, then the sum of moment around A will be equal to m times A times the distance between this MA and the point considered, which is here E. Now, what is the distance between this A here and this? So guys, don't forget that this A is at the center of mass. Now, what is the distance of this A here and big A? It is this one. So it is 1/2, so it's 0.5. At the same time, guys, what is the sum of moment around A? What are the forces causing a moment around A? In fact, the friction force and the normal force are passing through A, so they have a zero moment. The only force that doesn't have a zero moment is the weight of this crate. This weight here has a moment around A, so this can cause the rotation only. Now, what is the moment around this A? It's the weight times 0.5 over 2, which means, on the other hand, the sum of moment around A is the weight, which is 150 times the gravity, times 0.25. So if you equate these two sides, then you can have A. Don't forget, guys, that this mass is 150, all right? It's not the whole mass, it's only the mass of the crate. And then A will be equal, I think I have the value. Yes, if you simplify this, and you simplify this and this so that you can have 2 here, then it will be 9.81 over 2. This means that A will be equal to 4.905 meters per second squared. A. Now, guys, what do I have to do? If I know A, I can take the whole system, all right? So if I know A, I can take the whole system. And in this case, what are the forces exerted on this whole system? I have the weight of the whole system, which is the weight of the crate, 150, plus the weight of the cord, which is 10. I have 2 normal forces here. I have this P. And guys, don't forget that I cannot say that there is a friction force between the crate and the cart now, because it is internal now. I'm taking the whole system. And at the same time, I cannot say that there is a normal force between the crate and the cart, because it's also internal, right? So let's write this down. When we take the whole system as our free body diagram, then in this case, the frictional force between the cart and the crate, as well as the normal force, not these 2 normal forces, no, the normal force between the crate and the cart are both equal to 0, because they are internal now. Internal forces are in this free body diagram, right? But guys, if I take this as my whole free body diagram, then these forces will be internal, right? So they are equal to 0. Now, what are the remaining forces to find P? In fact, guys, if I take a look, I know that this normal force and this normal force, as well as this weight, they are all vertical, which means I only have one horizontal force, which is P. So I can say that the sum of forces in X direction is equal to MAX. And then this means, guys, that P is equal to M. And what M do I have here? M of the whole system, right? Which means it's 150 plus 10 times AX that I already found, which is 4.905, and then P will be equal to 785 Newton. Any question, guys?